Hello there, and welcome. Tonight, we will begin with a question that seems simple but carries a weight that can bend the heart. Is Earth truly the best home for life? Or is it only one among countless possibilities? Perhaps not even the most welcoming one. For as long as we've looked at the sky, we have carried the quiet assumption that our world is special. The oceans, the mountains, the forests, all of them whisper that Earth is uniquely suited to cradle life. And in many ways, it is true. Here we are, breathing, thinking, wondering. This small blue planet gave rise to consciousness, to art, to stories like this one. But if we look closer, if we stretch our gaze beyond comfort, a deeper possibility appears. What if Earth is not the pinnacle of habitability, but only an average attempt? What if the cosmos holds planets that are even more fertile, more stable, more enduring than ours? Pause with that thought for a moment. The ground beneath you, the air around you, the light of the sun, all feel inevitable. But they are not. They are accidents, outcomes of chance piled upon chance. For billions of years, Earth has carried life, but not without upheaval. Scientists often speak of 5 great mass extinctions, though the record shows many crises in between. And perhaps we are living through another now. Entire lineages vanished, oceans boiled and froze, skies darkened, continents split, climate shifted. And through it all, life clung on, fragile as a flame in the wind. Is that the mark of a perfect world? Or is it the mark of a world just barely good enough? Some scientists have dared to ask whether Earth might not be the best possible stage for life. Perhaps, they suggest, there are super-habitable worlds, planets larger, richer and more stable, circling stars that shine longer than the sun. Worlds with thicker atmospheres, gentler climates, stronger shields against radiation. Worlds where life would not only emerge, but flourish in abundance, protected for billions of years more than we can imagine. If that is true, then Earth is not the jewel of creation. It is a survivor, but not a masterpiece. And if that is true, then we must ask, what does it mean for us to live on a planet that is precious, but not perfect? Imagine drifting slowly above Earth as astronauts do. From space, the planet glows like a delicate lantern, blue seas, white clouds, continents colored by deserts and forests. It seems serene. Yet within that serenity lies chaos. Storms that erase coastlines, volcanoes that bury valleys, asteroids that scar continents. Earth is alive, yes, but also dangerous. Life here exists not because the planet is gentle, but because it endures the harshness. Perhaps elsewhere, in the vast silence beyond, there are planets where the balance is easier, where life does not fight so hard just to remain. This thought does not belittle Earth. If anything, it deepens its wonder. To realize that our world may not be the best, yet still it carried us, makes it even more miraculous. It is like realizing that a fragile boat crossed an impossible ocean. The boat may not have been perfect, but it brought us here. And so tonight, our journey will follow this question. Is Earth special because it is uniquely suited for life? Or is it only special because it is ours? We will walk through the history of extinctions and survivals, through the scientific criteria for super-habitable planets, through the discoveries of exoplanets that may outshine our own home. And as we walk, we will hold this paradox. To love Earth fully is also to admit its imperfection. Astrobiologist René Heller once suggested, provocatively, that our planet might even be less than mediocre, an idea drawn from theoretical models rather than direct evidence. Not only are there better candidates for life, but they may even be more common. Imagine that. The world we call extraordinary may, in the grand library of planets, be only a modest volume among masterpieces. Yet we read from it because it is the one in our hands. What does that do to our sense of belonging? What does it mean to be children of a planet that may not be the best nursery? Let the thought expand. If we are not the peak of habitability, then our existence is even more fragile than we believed. Our story is not inevitable. It is the result of chance upon chance, filtered through catastrophe and survival. To be alive on such a world is not to be chosen. It is to be lucky. And luck is fleeting. But perhaps this fragility is itself the gift. For in knowing that Earth is not the eternal, perfect home of life, we learn to cherish its imperfections. We learn to see our storms, our deserts, our precarious balance as reminders that nothing is promised and everything is precious. As we begin this exploration together, hold the image of Earth as both cradle and challenge, both shelter and trial. It is beautiful not because it is flawless, but because it endured enough to let us wander. And so, here is the invitation. Join me as we look at Earth, not as the unquestioned jewel of the universe, but as one fragile thread in a vast cosmic tapestry. Together, we will search for what it means to be alive on a planet that may not be the best, but is the one we call home. If this thought resonates with you, let it drift outward. Like ripples across still water, let it reach another curious soul. And if you wish to walk further on this journey, take a moment now. Like this video, subscribe to the channel, and share it with others who wonder. Because the search for life is not only about science, it is a mirror of ourselves, and to wander together is its own form of survival. There is an old principle in science, simple yet unsettling, called the principle of mediocrity. It whispers that we are not special, that nothing about Earth, or humanity, or our moment in time is unique. It suggests that we are just another planet around, just another star in just another galaxy, orbiting in the middle of nowhere. And for much of modern astronomy, this principle has been the compass. Whenever we discover something new, we assume Earth is not the exception, but the rule. This idea has deep roots. For centuries, humans believed Earth was the center of everything. The sun, the moon, the stars, they revolved around us. Then came Copernicus, Galileo, and Kepler, and the illusion fell. We were not the center. We were not even the anchor. We were drifting, one planet among many. That shift was not only scientific, it was existential. It forced us to look at ourselves with humility. From there, the principle of mediocrity became almost a habit of thought. If Earth is not central, then perhaps it is not special in any way. When we found planets around other stars, we assumed many would be like ours. When we searched for life, we looked for Earth-like conditions: liquid water, rocky surfaces, atmospheres like our own. The logic was simple. If life arose here, surely it can arise elsewhere under similar circumstances. This assumption has guided decades of exploration. We point our telescopes at the skies, searching for small shadows as planets pass in front of their stars. We measure the dimming of light, calculate orbits, estimate sizes, and when a planet looks Earth-like, we mark it with hope. Perhaps there, we think. Perhaps there is another Earth. But what if this principle is misleading us? What if Earth is not a good template, but an exception in a different way? Not because it is perfect, but because it is barely adequate. Consider the record of life here. Earth has hosted living beings for billions of years, but it has never been a gentle stage. The earliest oceans boiled under asteroid impacts. The atmosphere shifted violently, drowning early organisms in oxygen when photosynthesis appeared. Ice ages locked the planet in snow. 5 times mass extinctions swept the biosphere, erasing most of what had grown. Even now, the climate teeters under human influence. Does this look like a perfect cradle for life, or a battlefield where survival is rare? 2 researchers, René Heller and John Armstrong, dared to put this suspicion into words. In 2014, they proposed that Earth might not be the best planet for life at all. They described the idea of super-habitable worlds, planets that could be more favorable to life than Earth has ever been. According to them, we have been assuming mediocrity in the wrong direction. Earth is not the average. It might be worse than average. Pause with this paradox. The principle of mediocrity tells us we are ordinary. But Heller and Armstrong suggest we may be less than ordinary, that the universe may contain planets far better suited for life than ours. Imagine that. We who thought ourselves central, then average, may discover that we are living on a world that is not even at the top of the list. What would it mean if Earth were not the best? If we are only one fragile attempt among many more promising possibilities? To understand this, think of the assumptions we make when searching for life. The standard model is simple. Look for planets like Earth. If life exists here, then similar conditions should yield similar outcomes. It is a safe bet, a way of narrowing infinite possibilities. But it is also a bet shaped by bias. We assume Earth is the gold standard because it is all we know. This is a kind of cosmic provincialism. Just as ancient people thought the sun revolved around Earth because they saw it rise and set each day, we think Earth must be the best because it is the one that bore us. But perspective can be deceiving. The sun does not circle Earth, and Earth may not be the best cradle for life. Consider the principle of mediocrity from another angle. If we are not special, then why should our planet be the peak of habitability? If there are billions of stars, billions of planets, why assume our world is the model and not the exception? Why assume life elsewhere must look like ours, breathe our gases, walk on worlds like this one? Perhaps the mediocrity lies not in Earth's ordinariness, but in our assumptions. Perhaps life is common, but Earth is a difficult home, a place where survival is always under threat. Perhaps other planets are not just possible, but more welcoming, more abundant, more generous. This line of thought shifts our perspective. Instead of seeing Earth as the average, we begin to see it as precarious. Instead of seeing it as inevitable, we see it as improbable. Life here exists not because the planet is perfect, but because it endured imperfections. The principle of mediocrity, in this sense, dissolves into humility. We are not special, and our planet may not be either. Imagine standing at the edge of a forest after a storm. Trees are broken, soil washed away, branches scattered. Yet in the clearings, small shoots of green push upward, fragile but determined. That is Earth. Not a paradise designed for life, but a storm-tossed stage where life nevertheless persists. The miracle is not perfection. The miracle is survival. When scientists talk about super-habitable planets, they are not indulging in fantasy. They are asking, what if there are worlds where the storms are gentler, the climate steadier, the chances of survival greater? Planets with longer-lived stars, thicker atmospheres, more stable orbits. Worlds where life would not only cling, but thrive. If such planets exist, then Earth is not just mediocre, it is less. This realization reframes our search for life. We are not only asking, is there another Earth? We are asking, are there worlds better than Earth? And if so, what does that mean for us? Are we children of an imperfect cradle, destined to struggle? Or are we simply one of many experiments, living proof that even difficult planets can produce consciousness? Pause again. Feel the humility of this possibility. The universe does not arrange itself for our comfort. It offers what it offers. Some worlds barren, some fertile, some fragile, some abundant. We happen to emerge here not because Earth was the best, but because it was possible. The principle of mediocrity began as a correction to arrogance. It told us we are not central. Now, super-habitability corrects the correction. It tells us we may not even be average. Both lessons point in the same direction: humility. To be alive at all is rare. To imagine we are the peak is hubris. To accept that we are not is wisdom. And yet, this recognition does not diminish Earth's wonder. If anything, it amplifies it. To know that our planet is not the best, but still gave rise to us, makes it even more miraculous. Like a cracked vessel that still carries water, Earth has held us long enough for consciousness to bloom. Its imperfection is not a flaw. It is the stage on which we stand. As we continue, we will look more closely at these ideas of super-habitability. We will examine what makes a planet more welcoming, more stable, more enduring than Earth. And we will ask, if such places exist, why are we here? Why on this fragile world with its storms and extinctions and precarious balance? Perhaps the answer is not in the cosmos, but in ourselves. For now, let the thought ripple outward. Earth may not be the best, but it is ours. To share that reflection is to share gratitude. If this question stirs something in you, let it drift like a quiet signal across the night sky, waiting for another mind to receive it. When we call Earth a cradle of life, the phrase carries an image of gentleness. A mother holding her child, a sanctuary that nurtures and protects. But if we read the history of our planet carefully, the cradle looks more like a storm-tossed vessel. Life here has not been carried smoothly. It has clung through chaos, endured calamities, and survived narrow windows that could easily have closed. Consider the story of extinctions. 5 times in the deep past, life on Earth was nearly erased. The Ordovician extinction, more than 400 million years ago, erased much of ocean life, likely influenced by glaciations and other complex shifts in climate and sea levels. The Devonian extinction followed, stripping away reefs and countless fish that had ruled the seas. The Permian extinction, the Great Dying, was worse still, extinguishing nearly 90% of all species, leaving the world barren and still. Later, the Triassic extinction thinned life again, before the Cretaceous brought the death of the dinosaurs. Each time, life staggered. Each time, it began again, fragile and new. If Earth were the perfect home, would it not have spared its children such violence? And what of the present? Many scientists warn that we are now in the midst of a 6th extinction, driven not by asteroids or volcanoes, but by ourselves. Forests vanish, climates destabilize, oceans acidify. Species disappear at rates far above the background of ordinary evolution. Life continues, yes, but the balance trembles. The cradle rocks, and we are the ones shaking it. This does not sound like a planet designed for permanence. It sounds like a planet on the edge, where life survives because it adapts, not because it is guaranteed. The sun, too, reminds us of Earth's fragility. Our star is not eternal. It is middle-aged, burning hydrogen at a pace that will one day exhaust its core. Slowly, almost imperceptibly, it brightens. Astronomers estimate that within 1 billion years, perhaps less, Earth will grow too hot for complex life. The oceans will evaporate, the atmosphere will thin, and the cradle will break. For a while, microbes may persist in niches underground or high in the atmosphere, but the era of forests, animals, and thinking minds will be over. Think about that timescale. Life took 4 billion years to climb from chemistry to consciousness. Yet the window for complex life on Earth may be only a fraction of that. Perhaps 1 billion, perhaps 2 at most. Compared to the age of the sun, compared to the span of stars that can live for trillions of years, this is brief. Earth offers a short candle flame, not an endless torch. This is one of the sharpest arguments against Earth's supposed perfection. If life requires billions of years to evolve, but planets like ours can only support it for a short slice of time, then perhaps Earth is not the ideal. Perhaps it is a narrow path through a dark forest, one where most travelers stumble before reaching the clearing. And still, even within this narrow path, survival has been precarious. The atmosphere itself has wavered between poison and promise. Early Earth was suffused with methane and carbon dioxide. Oxygen only appeared after microbes learned photosynthesis, flooding the air with a gas that was at first toxic to most living things. Later, ice ages covered the world, perhaps entirely, in snowball states that tested the resilience of every lineage. The conditions we now take for granted, blue skies, breathable air, liquid oceans, are recent, fragile, and temporary. Ask yourself, does this sound like the best of all possible worlds, or like one of many experiments lucky to last as long as it has? Some scientists frame it starkly. Life on Earth is not evidence of perfect habitability, it is evidence of persistence. The planet is not a gentle mother, but a demanding teacher, one that threatens to erase its pupils at every turn. To survive here is not to live in paradise, it is to endure catastrophe again and again. And yet, here we are. That fact alone is enough to stir awe. Against the odds, life has not only persisted, but flourished. Out of ice, fire, and extinction, forests rose, oceans teemed, animals walked, and consciousness awoke. Our species is both fragile and improbable, and every breath we take is testimony that survival can bloom even in imperfection. Still, humility requires us to admit that Earth's gift may be temporary. The sun grows warmer, the climate grows unstable, the balance grows thinner. If we imagine ourselves as eternal, we blind ourselves to the reality that this planet, as it is, cannot cradle us forever. The clock is ticking, even if its hands move too slowly for our lifetimes. Now, imagine other stars. Red dwarfs, small and dim, can burn for trillions of years, longer than the age of the universe itself so far. Orange dwarfs, slightly smaller than the sun, can shine 10 times longer. If complex life requires long spans to evolve, then perhaps such stars, not ours, are the true nurseries. Their planets may enjoy stability for eons beyond what we can imagine. Earth's fragility, by contrast, may mark it as less than ideal. Picture a library of planets. On one shelf lies Earth, battered, imperfect, yet alive. On other shelves lie worlds we have not yet seen, perhaps larger, more stable, more enduring. If such worlds exist, then our story is not the measure of life's possibilities. It is only one among many. We are not the model, we are the accident that worked. And yet, accidents are powerful. They remind us that life does not require perfection, it requires possibility. Earth gave us that possibility, even if only for a short while. Its storms, extinctions, and fragile balance do not erase its gift. They define it. To know that survival is not guaranteed makes our existence more precious, not less. As we move forward in this journey, we will examine what scientists imagine when they describe super-habitable planets. We will ask what conditions might make a world not just adequate, but abundant. We will compare Earth's fragility with the resilience of other possibilities. And in doing so, we may learn something about ourselves. That our task is not to claim perfection, but to honor survival. For now, hold the image of Earth as both cradle and crucible. It is the stage that gave us life, but also the fire that tested it. Its imperfection is the reason we are cautious. Its fragility is the reason we are humble. And perhaps in that humility lies the first step toward wisdom. If this thought moves within you, let it ripple softly, like wind across tall grass. Share it not as instruction, but as an echo. For echoes are how fragile voices survive. When we look at the night sky, we often imagine another Earth. A twin world, circling a distant star, blue with oceans, green with forests, white with clouds. The phrase Earth-like has become a shorthand for possibility, for hope. If we can find another planet like ours, we think, then life might not be alone. But in 2014, two researchers, Renee Heller and John Armstrong, invited us to shift this imagination. What if Earth itself is not the best we can hope for? What if there are planets even more suited for life, planets that do not just resemble Earth, but surpass it? They called these worlds super-habitable. The phrase itself feels strange. We are used to thinking of habitability as a binary. A planet either supports life or it does not. But Heller and Armstrong proposed a spectrum, with Earth not at the peak, but somewhere in the middle. On this spectrum, some planets could offer conditions even more favorable to life's flourishing than our own home ever has. Pause and imagine this. Earth is not the crown jewel, but one of many stones. Some may shine brighter, last longer, give more generously. Life on Earth is proof that habitability exists, but not proof that it cannot be improved upon. What then makes a planet super-habitable? The first factor is size. Earth is modest in mass, large enough to hold an atmosphere, but not so large that it crushes life. Yet a planet 1 to 2 times Earth's size, with roughly twice the mass, may be even better. Such a planet would maintain tectonic activity longer, recycling carbon and stabilizing climate. It would hold a thicker atmosphere, better shielding against radiation and helping to regulate temperature. It would provide more surface area, more niches, more opportunities for ecosystems to diversify. A larger planet also means stronger gravity, which allows more gases to dissolve into oceans. This enriches the chemical soup from which life feeds. In such seas, nutrients would circulate more efficiently, fueling more vibrant biospheres. Earth, by comparison, may be lean. A super-habitable world would be generous. The second factor is the host star. Our Sun is a yellow dwarf, stable but limited. Its lifespan is about 10 billion years, and we're already halfway through. As we saw before, Earth's window for complex life is narrow. But stars slightly smaller, orange dwarfs, often called K-type stars, burn longer and steadier. They shine for 20 to 40 billion years, sometimes more. That is time enough, not only for life to arise, but for it to flourish for eons beyond our imagination. Such stars also emit less harmful ultraviolet radiation than the Sun, reducing the danger of DNA damage. Their planets would need less protection, fewer shields. Life could thrive more easily under their softer light. Imagine a sky slightly dimmer than ours, glowing with the steady orange of a gentler star, shining for trillions of dawns. That is the stage of super-habitable worlds. The third factor is climate stability. Earth's axis is tilted, producing seasons that can be both fertile and harsh. Its orbit is slightly eccentric, creating variations in distance from the Sun. Over millions of years, these cycles contribute to ice ages and warming periods. A super-habitable planet, by contrast, might orbit in near-perfect circles. Its tilt would be modest, producing mild seasons. Its climate would be steady, predictable, allowing ecosystems to flourish without catastrophic swings. Where Earth offers turbulence, a super-habitable world would offer calm. The fourth factor is geological activity. Life depends on recycling. Carbon moving between rocks, oceans and skies, nutrients shifting from crust to soil to plants. On Earth, tectonic plates perform this function, driving the carbon silicate cycle that stabilizes temperature over long scales. But Earth's tectonics may not last forever. A larger planet with more mass and a hotter core would sustain this activity longer. Its mantle would remain active, its magnetic field strong, its shield against cosmic rays enduring. And this leads to another factor: protection. Earth is shielded from deadly radiation by its magnetic field, generated by the motion of molten iron in its core. Without it, solar winds would strip away the atmosphere, leaving the surface barren, as happened to Mars. A super-habitable planet, larger and geologically vigorous, might maintain an even stronger magnetic field. Its atmosphere would endure, its surface would remain safe. Moons also play a role. Earth's large moon stabilizes our axial tilt, preventing wild swings that could destabilize climate. It also produces tides, stirring oceans, creating fertile coastal zones where early life may have thrived. A super-habitable world might have an even larger moon, 10% of its mass, providing stronger stabilization, richer tides, and greater protection against asteroid impacts. Where Earth balances precariously, such a planet would stand steady. Imagine walking on such a world. The gravity is slightly heavier, but not crushing. The air is thicker, carrying scents farther. The sky glows orange under a long-lived star. Oceans stretch wide, rich with nutrients. Forests spread lush and diverse. Storms come gently. Climates shift slowly. Extinctions are rare. Life does not merely survive here, it flourishes. Contrast that with Earth. Our climates have swung violently. Our atmosphere has shifted from poison to promise. Our oceans have frozen and boiled. Our continents drift and collide. Our history is scarred with extinctions. We are alive not because Earth was perfect, but because life found ways to endure imperfection. Super-habitable worlds remind us that survival could be easier elsewhere, that the struggle we see as natural may not be universal. That life does not require hardship to thrive. On other planets, evolution could proceed with fewer catastrophes, giving rise to richness we can hardly imagine. And yet, these ideas are not fantasy. They are grounded in astronomy. Out of more than 5,000 exoplanets discovered, some already fit parts of this description. Larger than Earth, orbiting orange dwarfs within habitable zones. A handful, perhaps 24, look like candidates for superhabitability. They are distant, hundreds or thousands of light years away, but they are real. They whisper that Earth may not be the best, that better cradles exist. What does this mean for us? It means our sense of uniqueness must bend again. Just as Copernicus removed Earth from the center, just as Darwin removed humans from the pinnacle, superhabitability removes Earth from perfection. It tells us we are lucky, but not privileged. We are one among many possibilities. Pause here and let that thought echo. The world that bore us is not flawless. It is fragile, storm-tossed, precarious. To know that better worlds may exist does not diminish Earth's wonder. It deepens it. Because what makes our story remarkable is not that we live on the best planet, but that we live at all. In the next step of this journey, we will explore in more detail the criteria that define superhabitability: mass, atmosphere, oceans, stars, moons. We will ask what each one contributes and why Earth, for all its beauty, may fall short. And as we walk through these ideas, we will carry a paradox in our hands: that we are precious not because our world is perfect, but because it is imperfect and yet alive. For now, let the thought drift outward like starlight traveling across darkness. If it resonates with you, let it shine quietly into another mind. For in sharing wonder, we extend the fragile flame of life a little further into the night. When we speak of a planet as habitable, the image that comes to mind is simple. Liquid water on the surface, an atmosphere to breathe, temperatures within a narrow band of comfort. But habitability is not a single threshold. It is a tapestry woven of many threads: mass, atmosphere, geology, oceans, stars, and moons. Earth, for all its resilience, may not weave these threads as tightly as it could. To imagine a superhabitable world is to imagine a planet where each of these factors is tuned a little closer to harmony. The first thread is mass. Earth is large enough to hold an atmosphere, but not so large that gravity crushes life. Some models suggest that a planet somewhat larger, perhaps up to twice Earth's mass, could offer advantages, though the balance is delicate, too much gravity, and atmospheres or geology might evolve in less hospitable ways. Such a world would hold on to its atmosphere more tightly, protecting it from solar winds that strip gases away. Its stronger gravity would keep oceans from evaporating too quickly, stabilizing climate over billions of years. At the same time, it would maintain tectonic activity longer, recycling carbon dioxide and regulating surface temperature. Earth may eventually cool, its tectonics fading. A larger planet would endure. The second thread is atmosphere. Ours is thin enough to see stars through, but fragile against disruption. A super-habitable planet might have a denser atmosphere, rich in nitrogen and carbon dioxide, shielding the surface from harmful radiation and buffering against temperature swings. Under such skies, climates would shift more gently, giving life time to adapt. The atmosphere would act like a blanket, steadying warmth, protecting oceans, nurturing ecosystems. Earth's atmosphere, by contrast, has been volatile. Once thick with methane, later spiked with oxygen, now destabilized by human industry. A thicker, steadier sky would give life not only protection but constancy. The third thread is oceans. On Earth, water covers 70% of the surface, but deserts and ice still sprawl. A super-habitable planet might balance land and sea more evenly, perhaps 60% ocean, 40% land. Too much water, and continents vanish, too little, and deserts dominate. But a balanced mix provides coasts, estuaries, rivers, wetlands, all fertile intersections where life thrives. Oceans on a larger planet would also dissolve more gases under higher pressure, fueling richer chemistry. Microbes would bloom, ecosystems would diversify, and food chains would deepen. Earth's seas sustain us, but they are modest. On a super-habitable world, they would be generous. The fourth thread is geology. Life does not flourish in stillness, it requires cycles. On Earth, plate tectonics recycles carbon, driving the long-term thermostat of climate. Without tectonics, carbon would lock into rocks, temperatures would plummet, and oceans would freeze. Or the reverse. Carbon would accumulate unchecked, and the planet would suffocate in heat. A super-habitable planet, larger and hotter inside, might keep its tectonic engine running for longer. Mountains would rise and erode. Volcanoes would breathe gases into the sky. Continents would drift. Oceans would deepen. Each motion would keep climate stable, each cycle extending the timeline for life. The fifth thread is magnetism. Earth's molten core spins and churns, creating a magnetic field that shields us from cosmic rays. Without it, solar winds would strip our atmosphere, and the surface would be bombarded with radiation. Mars, smaller and colder, lost its magnetism long ago, and with it most of its atmosphere. A super-habitable planet, if it had greater mass and internal heat, might sustain a stronger magnetic field, perhaps enduring for billions of years. Its skies would remain thick, its seas full, its surface protected. Where Earth risks fading, such a planet would endure. The sixth thread is temperature. Life is fragile to extremes. Too cold and water freezes. Too hot and proteins unravel. Earth orbits in the so-called habitable zone, but only just. We are close to the inner edge. As the sun warms, we will cross it. A super-habitable planet would orbit slightly farther from its star, in a position safe against future warming. If the star is smaller, an orange dwarf, then the planet could enjoy stable temperatures for tens of billions of years. Seasons would be milder, climate steadier, and life would have time not only to emerge, but to flourish in abundance. The seventh thread is moons. Earth's large moon is a rare gift. It stabilizes our axial tilt, preventing wild swings that could freeze or overheat the planet. It creates tides, stirring oceans, nurturing the chemical pools where life may have begun. A super-habitable planet could possibly host an even larger moon, perhaps 10% of its mass, providing stronger stability, richer tides, and greater protection from impacts. Where Earth benefits modestly, such a planet would benefit abundantly. The eighth thread is diversity of environments. Life thrives not only in stability, but in variety. Forests, coasts, mountains, deserts, each offers niches, challenges, opportunities. A super-habitable planet with greater mass and surface area would offer more environments. Its climates would range, but gently, without violence. Its landscapes would be broader, more fertile. Diversity would not mean chaos, it would mean richness. Evolution would have more space to play, more paths to explore. Now imagine all these threads woven together. A planet 1.5 times Earth's size, orbiting an orange dwarf star with a thick atmosphere, balanced oceans and continents, active tectonics, strong magnetism, a large moon, and gentle climates. Life there would not cling through extinctions, it would flourish in continuity. Evolution would have billions of years more to create complexity. Where Earth offers fragility, such a world would offer abundance. And yet, there is humility in this vision. Earth gave us consciousness. It carried us far enough to wonder about other worlds. A super-habitable planet might carry life farther, but we cannot know. Perhaps its abundance would produce richness beyond our imagination. Or perhaps it would settle into equilibrium, never pressed by catastrophe, never pushed into intelligence. For here is a paradox. Hardship may have shaped us. Extinctions cleared space for new lineages, climate shifts forced adaptation, scarcity sharpened ingenuity. Without such pressures, intelligence itself might not have emerged. It raises a paradox. Worlds too gentle may bloom with life but never push it toward awareness. Perhaps Earth's very instability, the storms, the ice ages, the narrow escapes, was not a flaw but the sculpture of thought. Still, the criteria remind us of possibility. They tell us Earth is not the only recipe. They whisper that habitability is not fixed, but fluid. Some planets may be less forgiving, others more. And if the universe contains billions of stars, then surely some worlds surpass our own. Pause here. Picture such a world in your mind. Oceans stretching wide, forests deep, skies orange, tides strong, climates steady. Life flourishing not for 4 billion years, but for 10, 20 or more. Such a world is not fantasy, it is possible. And knowing that possibility changes how we see our own world. Earth is precious not because it is perfect, but because it is ours. Its imperfection shaped us. Its fragility taught us resilience. But to admit that other worlds may be better is to admit humility. We are not the center. We are not the model. We are only one story among many. As we move on, we will explore the stars themselves, the orange dwarfs, the red dwarfs, the suns that last longer than ours. We will ask what kind of light best nurtures life, and why our sun, steady as it feels, may be less than ideal. For now, let this thought drift outward like pollen on a breeze. If it stirs something in you, let it settle in another mind, gently, without urgency. For wonder is not diminished when shared, it multiplies. When we imagine life in the universe, we tend to picture it under a sky like ours, blue by day, dotted with stars by night, warmed by a sun that rises and sets with steady rhythm. Our own star feels inevitable, as though every world must circle something like it. Yet the cosmos reminds us otherwise. The sun is only one kind of star among countless others, and not the most common. And if life requires time and stability, then perhaps the sun is not the best lantern to guide it. Perhaps other stars provide gentler, longer light. Our sun is a G-type yellow dwarf. It is stable, relatively quiet, and it has given Earth warmth for 4.5 billion years. But its generosity comes with limits. A star like the sun burns brightly, but only for about 10 billion years. It is already halfway through its life. In the far future, perhaps within the next billion years, increases in the sun's brightness are expected to challenge Earth's ability to host complex life. Our window is closing, even as we tell these stories. Now consider orange dwarfs, K-type stars. Slightly smaller and cooler than the sun, they burn more slowly and last longer, sometimes 20 to 30 billion years, sometimes even more. Their light is softer, more golden orange than yellow, and they emit less destructive ultraviolet radiation. For a planet orbiting within their habitable zone, this means less danger to DNA, less need for shields, more time for evolution to unfold. Where our sun offers billions of years, a K-type star offers tens of billions. Imagine a world beneath such a star. Its dawns glow amber, its skies tinted warm, its days steady across eons. Life there is not pressed against a short deadline. It has time to experiment, to diversify, to build complexity at its own pace. Extinctions may still occur, but the timeline stretches wide, and survival has room to breathe. Red dwarfs, M-type stars, are even smaller, even longer lived. Some may burn for trillions of years, outlasting the universe as it is currently known. They are by far the most common stars, making up the majority in our galaxy. If longevity alone determined habitability, then these stars would be ideal. But red dwarfs come with complications. Their habitable zones lie close to the star, so planets there risk being tidally locked. One side scorched in perpetual day, the other frozen in endless night. Red dwarfs are also prone to violent flares, releasing radiation that could strip atmospheres and sterilize surfaces. Even so, some scientists believe life could adapt to such worlds. Atmospheres might redistribute heat, oceans might circulate warmth, life might thrive in twilight zones between day and night. Perhaps resilience finds a way, as it has here. But compared to orange dwarfs, red dwarfs are riskier. They promise time, but not always stability. So if we ask what kind of star is most likely to nurture life, orange dwarfs rise to the top. They are abundant, more common than stars like the sun. They are steady, longer-lived, gentler in their radiation. They sit in the sweet spot between brightness and calm, between longevity and stability. If super-habitable worlds exist, many may circle these quiet orange suns. Pause with this thought. The universe does not build itself for our comfort. The sun feels perfect only because it is ours. Yet from a wider view, it may be less than ideal. Out of billions of stars, only a small fraction are like it. If we had been born under an orange sky, we might consider that the standard. We would imagine all life blooming beneath amber dawns, not yellow ones. The principle of mediocrity reminds us. Our perspective is provincial. What feels universal is often particular. And yet, Earth has thrived despite the sun's limits. Our window is shorter, but it was long enough for life to emerge, for consciousness to awaken. Perhaps time does not need to be infinite. Perhaps it only needs to be sufficient. But still, the contrast humbles us. In a galaxy full of orange dwarfs shining 10 times longer, we live beneath a star already halfway spent. Imagine standing on a beach of a distant planet circling a K-type star. The tide rises under the pull of a large moon. The sky glows orange with dawn. Forests stretch lush and dense, nourished by a climate stable for billions of years more than Earth can promise. The creatures there are not rushing against extinction, not pressed by short cosmic deadlines. They have time. Evolution unfolds like a slow symphony, not a desperate race. If such worlds exist, and evidence suggests they might, then Earth is not the model, only one variation. We live beneath a sun that will end our habitability long before its light fades. Others may live beneath stars that carry them for eons longer. In this sense, our world is not chosen. It is simply possible. This realization changes how we search the skies. For decades, exoplanet hunters focused on finding Earth-like worlds around sun-like stars. But more and more, attention shifts to K-type dwarfs. They are abundant, they live longer, and their planets may be more forgiving. The dream is no longer just another Earth. The dream is a better Earth beneath a gentler star. Of course, each possibility carries paradox. Too much stability and evolution may stagnate. Too long a timeline and intelligence may never be pressed to emerge. On Earth, catastrophes shaped us. Extinctions cleared space, climate swings forced adaptation, scarcity drove ingenuity. Without such pressures, perhaps consciousness would not bloom. Perhaps a world too gentle would remain full of creatures but silent of thought. And so we are caught between extremes. Too violent and life fails, too calm and it never strives. Somewhere in the middle lies the fragile corridor where both survival and consciousness can emerge. Earth may have walked that corridor by chance. Other worlds may walk it with more grace. The stars we circle shape that chance profoundly. Pause again and feel the humility in this. The star above us is not eternal. It is not universal. It is one among billions, and it shapes the narrowness of our story. To recognize this is not despair. It is perspective. It reminds us that the universe is not arranged for us, and yet we arose within it. That contradiction is the wonder. As we move forward, we will look at the other ingredients that might make a planet super-habitable. Not just the stars, but the moons, the orbits, the balances that create stability. We will ask how many such worlds might exist, and whether we are living in the exception or the rule. And in asking, we will find again the thread of humility that runs through every cosmic reflection. We are not central, not eternal, but we are here. For now, let this thought drift outward like the light of distant suns. Gentle, steady, patient. If it touches you, let it glow softly in another. For light, like wonder, is not diminished when shared. It expands until even silence shines. When we think of habitability, we often picture oceans and atmospheres, sunlight and warmth. But there are quieter forces at work, subtler balances that protect, stabilize, and nurture life in ways we rarely notice. These forces are not always visible, but without them, Earth might have been barren or far less stable. To imagine super-habitability, we must look not only at stars and sizes, but also at companions, orbits and shields. Begin with the Moon. Earth's large moon is more than a satellite in the sky. It is a stabilizer, an anchor, a guardian. Without it, Earth's axial tilt would likely wobble far more dramatically, sometimes tipping steeply, sometimes straightening. These swings would produce extreme climate shifts, with ice sheets advancing and retreating unpredictably, forests turning to deserts, oceans freezing or boiling away. Life might endure such chaos, but it would struggle. The moon dampens this wobble, keeping Earth's tilt steady around 23. 5 degrees. Our seasons exist because of this tilt, but they remain within limits because the moon holds the axis firm. The moon also shapes tides. Twice a day, the oceans rise and fall, stirred not only by the sun's pull, but by the stronger hand of the moon. These tides created coastal zones where shallow waters mixed nutrients, where early life may have first adapted to shifting environments. In tide pools, organisms learned to survive cycles of flooding and drying, foreshadowing the leap onto land. Without tides, perhaps life would have stayed in the oceans, never venturing outward. The moon, then, was not just decoration. It was part of the story of complexity. Now imagine a super-habitable world with an even larger moon. If the moon held 10% of the planet's mass, its stabilizing effect would be stronger, its tides richer. Oceans would surge higher, stirring more nutrients, creating more fertile coasts. Climates would be even more stable, wobbling less across deep time. The planet would be guarded against impacts too, for large moons can deflect asteroids or absorb collisions. Such a world would not only endure more gently, it would thrive more deeply. Next, consider orbits. Earth's orbit around the Sun is nearly circular, with only slight eccentricity. This keeps the distance to the Sun almost constant, smoothing climate across the year. If Earth's orbit were more eccentric, climates would swing wildly. Scorching summers when close, freezing winters when far. Stability would falter, ecosystems would collapse. A super-habitable planet would orbit in an almost perfect circle, maintaining steady warmth. Its seasons would be mild, its climates predictable, its biosphere calm. Orbit also involves distance. Earth sits near the inner edge of the Sun's habitable zone. As the Sun warms, this edge creeps outward, threatening to push us into uninhabitability. A super-habitable planet would begin farther out, closer to the middle of its star's zone, safe for longer. If circling an orange dwarf, it would enjoy tens of billions of years of gentle warmth. Where Earth offers a precarious balance, such a planet would offer abundance of time. But orbits are not always solitary. Giant planets can play the role of guardians. Jupiter, with its immense gravity, shields Earth from some asteroids and comets, deflecting or capturing them. Without Jupiter, impacts might have been more frequent, perhaps catastrophic enough to halt complexity. In the architecture of solar systems, the arrangement of giants and smalls matters deeply. A super-habitable system might place a giant just beyond the habitable zone, sweeping debris away and protecting inner worlds. Earth benefits from Jupiter, but not perfectly. A better arrangement could reduce catastrophe without erasing diversity. Then there is the matter of shields invisible to the eye, magnetic fields. Earth's magnetic field extends far into space, a bubble deflecting solar winds and cosmic rays. Without it, high-energy particles would strip away the atmosphere, leaving us like Mars, dry, cold, exposed. The field exists because Earth's core remains molten, iron flowing and spinning, generating a geodynamo. As long as the core churns, the shield holds. But over billions of years, cores cool, fields fade, atmospheres leak away. Mars cooled quickly, its smaller size dooming it. Earth, larger, has lasted longer. Yet even ours will not endure forever. A super-habitable planet, more massive and hotter inside, would keep its core active longer. Its magnetic field would be stronger, more enduring, protecting atmosphere and life for eons beyond Earth's limit. Cosmic rays would be weaker at the surface, mutations fewer, survival easier. Where Earth offers a temporary shield, such a planet would offer a lasting one. All these elements, moons, orbits, giants, fields, compose the background conditions of habitability. We rarely think of them, yet they shape our existence as profoundly as oceans and air. Without the moon, our axis would wander. Without our orbit, climates would swing. Without Jupiter, impacts would rain. Without magnetism, our air would vanish. Life survives not only because of water and warmth, but because of stability, protection, and time. Imagine again a super-habitable world. Its moon stabilizes its tilt perfectly. Its orbit is circular and safe. Its star is gentle and long-lived. Its giant neighbor sweeps away debris. Its core burns hot. Its magnetic field strong. Its atmosphere thick and enduring. To live there is to exist within layers of guardianship, each protecting, each balancing, each offering life more room to grow. And yet, perfection may not be the point. Earth, with all its flaws, carried life to consciousness. Its wobbles, its extinctions, its catastrophes. These shaped us. Perhaps intelligence requires a measure of challenge. Too much stability and evolution may stagnate. Too little, and it collapses. Somewhere between chaos and calm lies the path to thought. Earth found it narrowly, precariously. Other worlds may walk it with more grace. This realization invites humility again. We are not here because conditions were perfect, but because they were sufficient. And sufficiency, not perfection, may be the true miracle. The moon steadied enough, the orbit balanced enough, the shield held enough. That was all life needed. Not a flawless stage, but a stage on which survival was possible. Still, it is worth imagining the better stage, not to diminish Earth, but to expand our sense of possibility. To know that moons can stabilize more, orbits can smooth more, shields can endure longer, is to know that life may thrive elsewhere with greater ease. And if life thrives elsewhere, then we are not the model but the exception, the children of a world that is adequate, not optimal. Pause here and let the image linger. A planet with a vast moon rising over orange skies, oceans pulled by tides twice as strong, climates steady as stone, a magnetic field humming deep below, shielding all who live above. Such a vision is not fantasy, it is science extended into wonder. As we continue, we will look outward to the exoplanets already discovered, thousands catalogued, dozens resembling Earth, a few perhaps surpassing it. We will ask how many may be truly super-habitable and what it means to imagine them while standing on our imperfect home. For now, let this thought ripple like a tide under a distant moon. If it stirs something in you, let it drift outward, not as instruction, but as invitation. For wonder grows not in isolation, but in the quiet company of others who ask the same questions beneath the same stars. For most of human history, the stars were lanterns beyond reach. They were points of light, steady and silent, with no evidence that they hosted anything more than our imagination. The idea of planets circling those distant suns was speculation, myth, or metaphor. Only in the last 3 decades has that veil lifted. Today we know that planets are not rare at all. They are everywhere. The galaxy is littered with them, billions upon billions, orbiting nearly every star we see. The first confirmed exoplanet discoveries came in the 1990s. They were strange worlds, nothing like Earth. One circled a pulsar, the corpse of a star, bathed in deadly radiation. Others were massive, hot Jupiters, giant gas planets hugging close to their stars, scorched and stormy. At first, astronomers wondered if our solar system was unusual, if rocky worlds like Earth were rare. But as telescopes improved, the picture shifted. The Kepler Space Telescope, launched in 2009, revealed thousands of exoplanets. Small worlds are not rare, they are common. Earth-like planets may number in the billions across our galaxy alone. Pause with that number. Billions of worlds, each with its own skies, its own gravity, its own stories we cannot yet read. The principle of mediocrity suggests Earth is only one among many, perhaps unremarkable. But the search also opens another question. Among all these planets, how many are truly welcoming? How many are merely adequate, and how many are better? Astronomers classify exoplanets by size, mass, orbit, and star. Some are Earth-sized, some super-Earths, some mini-Neptunes. Many orbit in what is called the habitable zone, the region where liquid water might exist on the surface. But habitability is more than temperature. A planet can be in the right zone and still be barren, like Mars. It can be too large, holding a crushing atmosphere, or too small, losing it entirely. It can orbit a star too violent, or follow a path too erratic. The habitable zone is a start, but not the finish. From the Kepler data, scientists have identified a few dozen candidates that might fit the description of super-habitable. They are larger than Earth, orbiting long-lived stars, sitting comfortably in stable zones. Some may have thicker atmospheres, stronger magnetism, more balanced oceans. Out of more than 5,000 exoplanets confirmed so far, perhaps 24 stand out as better homes for life than our own. 24 among thousands. Thousands among billions. One such candidate is Kepler 4442b, a rocky planet about 1.5 times Earth's size, orbiting an orange dwarf star about 1,200 light-years away. Its year lasts 112 days, its orbit nearly circular, its star steady. By some measures, it is closer to the ideal than Earth itself. Another is Kepler 186f, orbiting within the habitable zone of a red dwarf about 500 light-years away. Though its star is smaller and dimmer, its size and orbit make it intriguing. There is also Kepler 62f, about 40% larger than Earth, orbiting in the habitable zone of a smaller, cooler star. These are not fantasies. They are data points drawn from dips of starlight measured across years. The list continues. The the catalogue grows. Each planet is a whisper from the cosmos, a suggestion that Earth is not unique. Among them may be worlds with thicker skies, richer oceans, steadier climates. Worlds where life not only survives but blooms in abundance. And yet, we must be cautious. The data we have is limited. We measure starlight dimming as planets pass in front. We infer sizes and orbits, sometimes masses. Only recently, with the James Webb Space Telescope, have we begun to probe atmospheres. In one case, the atmosphere of a small planet showed traces of carbon dioxide and methane gases that hint at chemistry rich enough for life. But a hint is not proof. We are at the beginning of the story, reading only the first lines of a vast book. Still, the trend is clear. Planets are common, habitable zones are common, Earth-like worlds are common, and super-habitable candidates are real. Astronomers have identified roughly 24 planets that share some traits thought to be linked with super-habitability. As instruments sharpen, as telescopes extend their gaze, that number will grow. What once seemed fantasy is now a catalogue, and the catalogue is growing. Pause here and let the scale settle. 5,000 confirmed exoplanets, billions more awaiting discovery. Among them, dozens, perhaps hundreds, better suited to life than Earth. What does that mean for us, who once thought ourselves central, then average, and now perhaps less than average? It means humility again, and wonder. It means the universe is generous with possibilities. It means our planet is precious not because it is perfect, but because it is ours. Consider the irony. For centuries we searched for other Earths, imagining them as mirrors of our own. Now, as we look more closely, we begin to see that Earth itself may not be the ideal mirror. The planets we find are not only similar, but sometimes superior. Our search for copies may reveal improvements. Our longing for company may reveal that we are not the peak, but the prototype. This does not diminish Earth. If anything, it deepens our gratitude. To know that better worlds exist does not make ours less. It makes it more remarkable that we arose here, against odds, through extinctions and chaos. Earth's imperfections did not prevent consciousness. They shaped it. They forged resilience, creativity, awareness. Perhaps other worlds will bloom differently, but this is the one that bloomed us. As we look ahead, new telescopes promise even more. The James Webb has already begun probing exoplanet atmospheres, searching for biosignatures, gases like oxygen, methane, nitrous oxide, produced in patterns that hint at life. Future missions may go further, capturing direct images of Earth-sized planets, mapping continents, reading skies. In our lifetimes, we may glimpse the colors of alien worlds, the chemistry of their air, the signs of life beyond Earth. Imagine that moment. To see, not in imagination but in data, a planet with an atmosphere thick with oxygen, an ocean glinting with light, a sky rich with gases we recognize as living. Imagine realizing that life is not confined to this fragile world, but scattered across the stars, perhaps on worlds more welcoming than our own. The silence of the cosmos would shift, not to noise, but to recognition. We would know we are not alone. And yet, there is another possibility. Perhaps we will find only chemistry, only barren rocks and sterile skies. Perhaps Earth is rarer than we think, not because it is perfect, but because even adequacy is rare. If that is true, then our responsibility grows heavier. We are not one among many, we are one among few. Our survival becomes not only our story, but the story of consciousness itself. Either way, the search matters. To look outward is to see ourselves more clearly. Each exoplanet we find is a mirror, whether reflecting similarity or difference. Each reminds us that Earth is not inevitable, that life is not guaranteed, that survival is not to be taken for granted. Yet beyond catalogues and numbers lies a deeper question. What does it mean that we, of all places, arose here? For now, let this thought travel outward like the faint dimming of starlight, barely perceptible but filled with meaning. If it touches you, let it ripple softly into another. For questions, like planets, multiply when shared. We have walked through the science. The extinctions that scar Earth's history, the fragile balance of our sun, the criteria that might make other planets more generous, the catalogue of worlds already discovered. The picture that emerges is both humbling and startling. Earth is not the perfect cradle. It is not the peak of habitability. It may not even be average. Better planets may exist, circling gentler stars, waiting in silence. And yet, we are here. Not there, not on those imagined shores, but here. What do we make of that? This is the paradox of our place. If the universe offers better homes, why did we arise in this one? If habitability comes in degrees, why did consciousness bloom on a planet scarred by extinctions, tilted toward instability, bound to a star that burns too quickly? Why did thought emerge from a world that seems less than ideal? One answer is chance. Evolution does not plan. It does not wait for perfection. It simply unfolds wherever conditions allow. Earth was not the best, but it was sufficient. Its oceans held chemistry, its skies sheltered possibility, its accidents opened pathways. Out of those accidents, life arose. Out of survival, consciousness emerged. We are not here because Earth was the best. We are here because it was possible. But possibility alone does not quiet the question. Why not somewhere else? Why not on a super-habitable world with thicker skies, gentler climate, longer time? Perhaps the answer lies in timing. Evolution is slow and time is uneven. Many super-habitable worlds may be real, but too young for life to have matured. Perhaps we are early, living in a universe where better cradles exist but have not yet filled. If so, we are not special. We are simply first. Or perhaps intelligence requires hardship. Catastrophes may prune, but they also press. Extinctions clear space for new forms. Climate shifts force adaptation. Scarcity drives innovation. On Earth, our lineage was shaped not only by abundance but by trial. Without the asteroid that ended the dinosaurs, mammals might have remained small. Without ice ages, humans might never have spread. Without challenges, perhaps thought itself would not have sharpened. A super-habitable world, too gentle, might bloom with life but never push it toward reflection. In this view, Earth's flaws are not obstacles, they are sculptors. Still, we cannot know. We imagine, we speculate, we model. But the paradox remains. We are aware enough to see Earth's imperfections, yet bound to it. We glimpse better possibilities, yet cannot reach them. We know the odds, yet we are the outcome. That tension is what makes our reflection not just scientific, but philosophical. Pause with that tension. It is the silence at the heart of the paradox, the stillness between chance and necessity. We do not know why we are here, only that we are. We do not know if others exist, only that we can wonder. And perhaps that is the meaning, not to resolve the paradox, but to live within it. Think of a child raised in a poor home who grows into wisdom. The house was not perfect, but it was enough. The struggles shaped resilience, the scarcity sharpened gratitude. Perhaps Earth is like that. It was not the best home, but it was the one that formed us. Its storms taught us endurance. Its extinctions taught us humility. Its fragility taught us care. This reframes our relationship to Earth. If we thought it was perfect, we might take it for granted. If we know it is imperfect, we may treasure it more. Each forest, each ocean, each breath of air becomes not a gift of abundance, but a miracle of survival. To live on Earth is not to be chosen. It is to be lucky. And luck, once recognized, demands care. There is also wonder in knowing that we might not be alone, that other worlds may one day carry voices of their own. If life flourishes elsewhere, then Earth is not the sole story. But if consciousness is rare, then our fragility is even more profound. Either way, the paradox sharpens our responsibility. We are stewards not only of our planet, but of awareness itself. Imagine again those super-habitable worlds, lush forests beneath orange skies, oceans rich and deep, climates steady for billions of years. Imagine that they exist, but no voices rise there yet. Imagine that we, children of a lesser world, are the first to wonder. If so, then our task is not envy but guardianship, to keep this fragile awareness alive long enough to greet others, long enough to let the cosmos awaken in more than one place. And if no others exist, if even super-habitable worlds remain silent, then our responsibility grows greater still. Then we are the only voice, the only echo of the universe recognizing itself. In that silence, Earth's imperfection does not diminish us, it magnifies us. Against odds, awareness arose here. Against fragility, thought persists. That is not perfection, that is miracle. Philosophers sometimes ask whether the universe cares. The evidence suggests it does not. Stars burn, planets turn, life arises or does not with no preference, no intention. But meaning is not absent. Meaning is what we make of this fragile thread of existence. To know that Earth is not the best yet still gave us awareness is to know that meaning is not given. It is created. Pause once more. Let the paradox settle. Better worlds may exist, but we are here. Earth is fragile, yet it bore us. The cosmos is vast, yet silent. The meaning of this is not certainty, but wonder. Wonder that we can ask, that we can imagine, that we can care. And so the paradox becomes a mirror. We see not only Earth's flaws, but our own. We are not perfect, yet we endure. We are not eternal, yet we love. We are not central, yet we matter. Earth's imperfection is our imperfection, and its survival is our survival. As we near the end of this journey, we will turn toward reflection, asking what it means to live on a planet that may not be the best, but is the one we call home. For now, let the paradox echo outward, like a question carried on the wind. If it stirs something in you, let it ripple softly, not as an answer, but as an invitation. For in questions, as in planets, abundance lies not in certainty, but in possibility. The journey brings us back, as all journeys must, to the place we began. Earth. We have wandered through extinctions and survivals, through stars and moons, through the possibility of worlds more welcoming than our own. We have held the paradox that Earth may not be the best, and yet it is the one that bore us. Now, at the end, we pause to ask, what do we make of this fragile home, knowing it is imperfect, perhaps even less than average? One answer is humility. To know that Earth is not the peak of habitability is to know that life is not guaranteed. We are not inevitable. We are improbable, the outcome of a narrow corridor of chance. That recognition strips away arrogance, leaving only gratitude. Each forest, each ocean, each breath of air is not a given but a gift. To live here is not our right, it is our fortune. Another answer is responsibility. If Earth is fragile, then survival is not assured. The storms, the extinctions, the limits of our star roll remind us that this window can close. And if better planets exist but remain beyond reach, then Earth is not only our home but our only home. To care for it is not sentiment, it is survival. To damage it is not folly, it is self-erasure. The paradox sharpens into urgency. To love Earth is to protect it, because no other world is waiting for us now. Yet another answer is wonder. To imagine better worlds does not diminish ours, it expands our sense of possibility. Earth is beautiful, not because it is perfect, but because it is alive. Its flaws shaped us, its storms tested us, its imperfection forged resilience. Perhaps other worlds are gentler, but they have not yet spoken. Earth has spoken, and we are its voice. That is wonder enough. Pause with that thought. Earth is not the pinnacle, yet it bore awareness. Out of a storm-tossed planet circling a finite star, consciousness arose. Out of chance, meaning emerged. That meaning is fragile, but it is real. To live here is to hold it, briefly, like a flame cupped against the wind. The closing of this journey is not an answer, but an invitation. To live with humility, knowing we are not the center. To live with responsibility, knowing this world is fragile. To live with wonder, knowing existence itself is improbable. That is what it means to be children of Earth. And what of the silence of the cosmos? Perhaps better worlds wait, lush and steady, but still empty. Perhaps other voices will one day rise, but have not yet. Perhaps we are early or alone. The silence does not tell us, but it reminds us that awareness is rare. It reminds us that to carry it, even briefly, is a weight and a gift. Imagine time flowing like an endless river. Stars are born, blaze and fade. Galaxies spin for billions of years. Against that immensity, Earth is a moment, a flicker. Our atmosphere has existed only for a fraction of cosmic history. Our species has lived for less than an instant. And yet, in that instant, we have looked outward, measured starlight, imagined other homes. Against the silence, we have asked. That asking is our mark. The future stretches ahead with equal immensity. In 1 billion years, the sun will warm, oceans will boil, skies will thin. Earth's habitability will close. Long before the sun swells into a red giant, life here will fade. We are not eternal. The cradle will break. Yet the fact that we are aware of this, that we can imagine the future of our planet, gives us a kind of responsibility. We cannot hold the sun, but we can hold ourselves. We cannot stop time, but we can decide what to do with it. Our task is not to be eternal, but to be careful. To know that this brief window of habitability is all we have, and to make of it something that matters. Not power, not permanence, but care. To live lightly, to leave echoes, to share wonder. To be alive is to be temporary. To be temporary is to be precious. The silence of the cosmos also teaches us perspective. If we are alone, then our survival is the survival of awareness itself. If we are not, then we are still part of a fragile minority, voices scattered across stars. Either way, the lesson is humility. Either way, the response is wonder. Picture Earth as seen from space. A blue marble against darkness, glowing softly, wrapped in thin air, scarred and beautiful. To see it is to see fragility and resilience together. To love it is to love imperfection. To live here is to honor both survival and possibility. If better worlds exist, let them deepen our humility. If we are alone, let that deepen our responsibility. Either way, let wonder guide us. For wonder is the thread that turns knowledge into meaning, science into story, existence into life. The universe will not pause for us. Stars will burn, planets will turn, time will flow. But for a moment, here, now, we exist, we breathe, we wonder, we share. That moment is brief, but it is enough. And so, as this journey ends, we return not to certainty, but to silence. Silence not of absence, but of possibility. Silence like the stillness of night, holding everything within it. Earth may not be the best, but it is ours. In its imperfection, it gave us everything. In its fragility, it teaches us care. In its silence, it invites us to wonder. If this reflection has stirred something in you, let it linger. Let it ripple outward like starlight crossing the dark, like tides under a distant moon, like echoes in the stillness. Share it not as command, but as companionship. For to wander together is itself survival. And if you wish to walk further on this path of questions, let it drift gently. Subscribe, share, and join again. Not because answers wait, but because the asking is what makes us human. In the vast silence of the cosmos, to ask together is to be less alone. So we end here with silence, with gratitude, with wonder. The night continues, the stars remain, and Earth turns beneath them, imperfect, fragile, alive. Let that be enough.